Hi, my name is NAJIB and my matrix number is 05DKA20F1058. So, I am a part of this group members. So, a week ago, our lecturer, Sir Fauzi, has given us some tasks to do, that is Sieve test. So, today, I'm going to present about the objective. So, the first objective is to determine the classification particles size of soils that are used before piling. As we know, this test will separate or divided this soil according to their size, as, and also each sieve has their size too. So the next objective is to determine the weight and strength of grain sieve. As we know too, this sieve test separate this particular size of the soil according to their size. So we can know from each size there has strength of themselves and their weight of themselves. Okay, so that's all from me. Thank you. So next, I will pass to my friends, Muhammad Faizul Jeffrey, to present about the material and apparatus. Okay, Muhammad Faizul.
Hi, my name is Muhammad Faizul. I will explain about material and apparatus. The first one is soil. We are using 360 gram of soil. The second one is sieve. We are using 6 sieve with different type of weight and sizing. The third one is shovel to transport the soil into the sieve. The next one is weighing machine to weight the sieve and the mass of soil. And then the shaker to shake the sieve after we put soil into the sieve. The last one is rubber pestle.
Thank you, Mama Faisal. My name is Satya David Sanaga from class 3A, metric number 05DKA20F1052. This is my metric card. So for this lab, first procedure is we have to prepare the weighing machine to weight the soil and sieve. Next, put the sieve according to its size on the weighing machine and record mass of each sieve. Then, weight 360 gram of soil and put into the sieve. And then put the sieve and soil to the shaker and shake for 5 minutes. After 5 minutes, every sieve and its content are being weighed. The weight of soil particle retained on each sieve is calculated and the data is recorded and being compared with the original weight of the soil. Then, graph of percentage of transparency against sieve are plot on semi-log graph. And finally, percentage of transparency, transparency, the percentage of gravel, sand, clay in effective size, uniformity coefficient, and coefficient of curvature for soil is tested, is specified. So this is the data that being recorded. And for the data, I will pass the next slide to Waybyern Liban to explain about the data. Thank you.
Okay, thank you, Arthur. My name is Waybyern Liban. My matrix number is 05DKA20F1087, and I am going to continue this presentation by explaining the data that we have collected from the experiment. Okay, as we can see from the data, there are two types of grade, which is well-graded and uniform graded. A well-graded soil is a soil that contains particles of a wide range of sizes and has a good representation of all sizes, while for uniform graded, it is when all the particles present in the soil sample are around the same shape, same size and shape. The granular soil is known as uniformly graded soil. Okay, as we can see, in size sieve number 1, which is 300 milliliter, for well graded, the soil retained is 28.91, which is 91.97% final. For sieve number 2, which is 80 millimeter, the soil retained is 37.58 and 81.53% final. Next, for number 3, the soil retained is 64.87 soil retained and 63.51% final. Number 4, 20 millimeter sieve size. We have 111.46 soil retained and 32.55% finer. Next up, for number 5, we have 10 millimeter sieve size with a total soil retain of 46.51 gram and 19.63% finer. Last but not least, number 6, with a sieve size of 4.75 millimeter, we have a total of 70.67 gram soil retain and 0% finer. Okay, now for uniform graded, we have different data from the well graded. Okay, for sieve number 1, we have 9.68 gram total of soil retain and 97.31% finer. Next, for number 2, we have 18.25 gram soil retain and 92.24% finer. Number 3, with a sieve size of 40 millimeter, we have 35.89 gram soil retain while 82.27% finer. Next, number 4, we have 58.86 soil retain and a total of 65.92% finer. Number 5, with a sieve size of 10 millimeter, we have 203.69 soil retain while 9.34 is finer. Last but not least, for number 6, we have 33.62 gram of soil retain while 0% finer. Okay, now we move on to the graph. As we can see, the well graded soil is higher than the uniform. Sorry, the uniform graded is higher than the well graded. Okay, so in conclusion, the well graded, the coefficient of curvature (CC) for well graded is 1.16, while the uniformity coefficient (CU) is 5.09, and for uniform graded, the coefficient of curvature is 0.97, while the uniformity coefficient is 1.88. Okay, that is all for our data.